All right, folks, so let's take a look at another example of how to create a resistor circuit to achieve a specific equivalent resistance. So for this particular example, we're trying to get an equivalent resistance of 600 ohms, and we have this inventory of resistors to work from. So I am going to use the following notation in these problems to kind of keep things a little bit neater. If I've got a series resistance, I'm going to just use plus to indicate that these are two resistors in series, because we know that we add the resistances if they are in series. So that'd be like, resistor 1 connected to resistor 2. If two resistors are in parallel, I'm going to use the parallel notation, R1 parallel R2, to indicate that my two resistors are in the parallel arrangement. And if you look at the last video I posted in the assignment, that's got the equation that we can use for two resistances in parallel. So if you see this notation, that's what I'm doing. It's just a little bit quicker than having to write out the actual circuit. So let's take a look at starting to combine some stuff. I'm trying to get 600 ohms, and kind of where maybe the most intuitive place to start with is the 100 ohm resistors. If I just add together all my 100 ohm resistors, so that's 100 ohm resistors in series. If I add up all 5 of these, that's going to give me a total resistance of 500 ohms, which gets me pretty close to 600 ohms. But it doesn't get me exactly there. So what could I add to 500 to get closer to 600? Well, if I'm talking about just adding stuff in series, you may think about going to the 10 kilo ohm resistors. And if I add up all these 10 kilo ohm resistors or 10 ohm resistors in series, that's going to add up to 50 ohms, which gets me to 550 ohms. But then all I'm left with are these bigger resistors to choose from, and then I'm up over 800,000, tens of thousands of ohms. So it looks like just going based on series resistances probably isn't going to get me very close to 600 ohms. So let's take a different approach. This probably means I'm going to need to try some parallel combinations. So the next biggest resistor is 256 ohms. Now, if I do 256 ohms in parallel, let's think about this in series first. That's going to add up to what, 512 ohms, which is close to 600 ohms. If I take 512 ohms and connect a series 100 ohm resistor to that, that gets me to 612. That's pretty good. That's getting me a little bit closer than I was before. Still not quite getting exactly there. So let's start looking at some parallel combinations of these resistors. I already know I can get to 500 ohms with the 100 ohm resistors connected in series. If I take the 256 ohm resistor and connect that in parallel to the 256 ohm resistor, we know that two resistances that are identical when connected in parallel are going to result in an equivalent resistance that is half their value. So 256 ohm resistor, half of that is going to be 128. So 128 ohms. So I could try building this circuit. I've got my 100 ohm resistors connected in series. So I've got 5 of those. And what if I connect in series two parallel resistors? So plus my 256 parallel 256. And I'm going to put that in parentheses indicating that the 256 ohm resistors are in parallel, and I got all these 100 ohm resistors. Well, that adds up to 500. This parallel resistor adds up to 128. That adds up to 628. So again, pretty close to 600. Here I'm using a bunch of series resistors and one parallel resistor. Still not exactly uh, 600. So let's try this using my kilo ohm resistors. So obviously if I put a 1 kilo ohm resistor in series with any of these other resistors, it's going to be way bigger than 600. But what if I take a 1 kilo ohm resistor and make that parallel with a 1 kilo ohm resistor? Again, two parallel resistors that have the same value, and my equivalent resistance is going to be half that value. So in this case, that's going to be 500 ohms. And I hope you see what the easy solution is. I just need to add another 100 ohm resistor. Fantastic. So if I have a 100 ohm resistor in series with two parallel 1 kilo ohm resistors, and this is the notation I would use to write that. So the 1000 ohm resistors are in parallel, and I'm adding that 100 ohm resistor. Um, Spot on, that's going to add up exactly to the 600 ohms equivalency that I'm trying to calculate. Let's take a look at what that circuit might actually look like. So again, this notation is just an easy way of indicating my circuits. Here I've got a 100 ohm resistor, and that's connected in series to two resistors that are connected in parallel. And so that's going to be a 1000 ohm resistor, that's going to be a 1000 ohm resistor. And I know that this equivalent resistance is going to add up to 600 ohms, which is exactly what I'm looking for. So working through designing resistance circuits may take a little trial and error until you kind of get used to it. And you might not be able to get, based on what your inventory is, the exact value you're looking for, but give it a couple shots, see if you can get as close as possible. It takes a little practice to get an intuition for it, so good luck.